My name is Robert Höttger from Dortmund University of Applied Sciences and Arts, and I'm here to talk a little bit about the Eclipse CUXA project. And the Eclipse CUXA project is kind of the code base and the result of the international funded research project APPSTACLE. APPSTACLE started in beginning of 2017, and it's a cooperation of 20 partners across 4 countries, and the duration is 3 years, so until the end of 2019. And the idea behind the project is to establish an open ecosystem for the connected vehicle domain. There we of course want to use and utilize Eclipse IoT technologies, for example, because there, of course, we do not want to start from scratch, and there is a huge variety of technologies.
So you said this was connected vehicles. Can you tell us a little bit more about what that means?
Yeah. So it's the middle of 2018, and there are already approaches towards connected vehicles. All the OEMs already have mobile solutions to connect their vehicle to the internet. However, all these solutions are proprietary, and all the OEMs, the suppliers, they have their own solution, closed source solution, and they all invest manpower in order to have the infrastructure, to have, commercial protocol support or proprietary protocols and so on. However, there's no open source solution to that, so they all work on the same challenges, on the same issues, and actually if there was a common architecture, a common environment, they could actually spend their efforts towards their unique selling points and their actual innovation of, for example, autonomous driving approaches or advanced driver assistant systems and things like that.
So when you say connected, and the way you're describing it, it really sounds first generation, like the car connecting to the internet instead of cars connecting to cars. Am I correct in making that assumption that that's kind of first generation?
No.
Okay. Why am I being wrong?
Yeah. So one of the project partners in the project is Ericsson, and they have a huge research department that focuses on 5G connectivity. And this is something that we have a separate work package actually just for the connectivity part in the project. So, right now our demonstrators, they use the regular state-of-the-art communication technologies like LTE, for example. However, since we kind of have on our roadmap vehicle to X, so vehicle to anything communication, it may not only be the connectivity to the internet, it may also be, as you said, a vehicle to vehicle communication or vehicle to edge computing approaches, such that a smart traffic system or traffic lights, things like that, is also on the roadmap of the project.
So when you say connected, you really mean connected to potentially anything. Connected to the internet, you could get traffic information, weather information, that sort of thing. But connected to other cars, you expand the amount of information that's available.
Yes.
And then, of course, connected devices as well. So traffic lights you mentioned specifically, and the roads themselves even being, for example, devices. Yeah. Interesting.
I mean, we start from the easy part, so that is the internet connectivity, to have some cloud applications that run some analysis and feed the results back to the vehicle. But like edge computing examples are also on the roadmap.
And so this actually, when I commented about first generation, I was thinking more the closed source to proprietary implementations.
I see. All right.
Right. So it sounds to me like individual vendors are they're working within their own little sandboxes, whereas this sounds like it's much broader in scope.
Yes. I mean, with the environment that we're trying to establish. Of course, there are, since Eclipse is also industry friendly, they have the opportunity to add their proprietary protocols or whatever to existing protocols, MQTT or CoAP or other ones that are available. And also there are lots of technologies and things that we can reuse.
Sure. So basically through open source we allow open collaboration.
Exactly.
And
yes.
Basically everybody benefits.
Yeah.
So is there anything else you'd like to share about your project or the work? Or
yeah, I can outline some specifics about the technologies maybe. We currently have the idea of providing basically three components, three platforms. And that is the in-vehicle platform, the cloud platform, and an IDE. The IDE is focusing on providing all the front end to the users in order to do two things, and that is developing applications for the in-vehicle and developing cloud services on the other side. We do not use the conventional Eclipse IDE, but instead we thought that using Eclipse She for the IDE is a smart approach because it's cloud-based and Docker-based, and we have our initial implementations, our initial stack, Eclipse She stack there already. So this includes all the compiling process, the configuration, and so on. So basically, the user has the ability to just click on a link. The browser builds up the workspace, the repositories are checked out, the configuration is done, and actually you can start right in the code implementing new stuff, click building the target, configuring the target, and even deploying on a real device from that. So this really helps users concentrating on developing the application instead of doing all the configuration stuff and so on. This is one thing. Then last year we made a platform study for the in-vehicle part. We tried to figure out what is the best operating system to base our implementations. And we found, I don't remember how many platforms there were, maybe 8, I don't recall exactly. Everything is publicly available, by the way, on the publicly funded ITEA website. And we found that automotive-grade Linux would be the best approach. And afterwards, we started implementing our own layers for our CUXA layers, and also the building systems. So automotive-grade Linux uses the Yocto project and the open embedded environment, so it has a huge flexibility towards a huge variety of targets. Raspberry Pi is one of them that we currently use for convenient purposes. And the billing system then uses, depending on the target, we at the University of Applied Sciences and Arts in Dortmund, we have a smaller use case, play around use case. It's a small rover, and we have the CUXA layers. Then on top of the CUXA layers, we have the rover layers. For example, in the rover layers, there are services, AGL services for each of the sensors, and then applications on top that uses those services in order to provide information. And there is a small display, for example, and also a menu implemented, and you can click through the different parts of the menu and display data from all the services running on AGL. And it's pretty flexible, and our current approach is also quite promising. Something that I was not mentioning is the cloud side. That's our third platform. And there I guess there are the most benefits of the IoT stack, because currently we use Eclipse Hono for the cloud backend, we use Grafana for the front end, just displaying some data. Then we want to use Keycloak, Eclipse Ditto, Eclipse Hawkbit for rolling out new software, making over-the-air updates. What is else? A couple of other ones. We have an overview of the technologies we want to use on the web page as well.
So So now, this is, when we talk about connected devices, how does that actually manifest in vehicle? Right, so is the communication providing information to the driver? Is it affecting how the vehicle operates?
That's a good question. I mean, yeah. So one of our recent publications also outlines answers to this question, and it's basically about comparing the vehicle to a smartphone. Because in everybody's life, like the smartphone has a lot of sensors and is used on each day, and it provides like the runtime environments that you can install new applications and things like that. However, this kind of approach is very rudimentally implemented in just the very newest cars. And it's also not, as I mentioned in the beginning, not on a common basis. It's proprietary. So this is something that we want to target also. So applying a runtime environment on top of that, new applications can be installed. So this affects drivers, for example, with the opportunity to, well, there can be, for example, in the human-machine interface of the car, it can be a pop-up that tells to try out for free a new vehicle assistance systems for a couple of days. And then if the vehicle owner decides to buy or to use this feature, then he's supposed to buy it, or to buy a fixed amount or a regular monthly paid thing. So this is also something that we are targeting in the project.
Interesting. Okay, well, this has been great. So thank you for telling us about KUKSA and your research. It sounds interesting. And best of luck, and look forward to, I look forward to seeing the project code and the continued work into the future.
Yeah, thank you very much for having me.